All right, so now we're going to talk about forces and what they are and how we can use them to help us understand things. So, some examples of forces. A student punches a whiteboard with his hand. Gravity is a force. Electrostatic force, that's what is pushing and pulling on all the electrons and protons that we learned about earlier, or you can be bigger stuff than that too, but that's just another example of a force. A chair pushing on your butt. So you're sitting on the chair's pushing back up, that's a force. Strong and weak nuclear forces, that's what holds protons and neutrons together. If I jump off of a table, I'm pushing down on the table to jump off of it. So those are all examples of forces. So what are some examples of forces that you can think of? Okay, so really a force is any push or pull. It doesn't have to cause motion, although it many times will. And the important thing here is that it has a magnitude, so that means a size, like how much you're pushing, and a direction. And we learned earlier that something that's a number and a direction is called a vector. And so force is a vector. We have four fundamental forces, and they are gravity. So we're pretty familiar with that. All things with mass are attracted to all other things with mass. And since the Earth is so big, it has so much mass, that's kind of what dominates gravity around here, where we live. Okay, so electromagnetism, that's when opposite charges attract and similar charges repel. That's what we talked about with protons and electrons. Strong nuclear force holds protons and neutrons together. Weak nuclear force helps hold atoms together. Don't worry too much about those. They're important, but not for what we're going to be talking about in this class. Really, gravity is the main one that we worry about, and electromagnetism is kind of related to all the other ones. All right, so I'm going to tell you about my four favorite forces of physics. These are not the same as the four fundamental forces, but these are the ones that we deal with most in high school physics or physical science class. So number one, gravity. Yeah, that's pretty important stuff, right? Pulls stuff towards the earth. Number two, normal force. That's like the chair pushing up on your butt. This is what keeps you from falling through things or moving through things. Really, this is the electrostatic force. It's the electrons in your atoms repelling the electrons in atoms of other stuff. But we don't need to think about it on that small of a scale. We can just think about it as the chair pushing on your butt, your hand pushing up on a pencil, your face pushing on the wall when you get really frustrated and you smash your face into the wall. Please don't do that. Okay, moving on. So it's always going to be perpendicular to the surface that we are talking about. Perpendicular means at a 90-degree angle. So if my butt is pushing down on the chair is going to be pushing up at 90 degrees to the surface, right? So straight up in this case. It gets tricky when you're on a ramp and on a slant, but we'll talk more about that in a minute. Number three, friction. Again, this is really electrostatic force, but we can think about it, we have some other tools to help us think about it on a more human scale. So friction always resists movement, meaning that if something is moving, friction is always going to be pointing in the opposite direction, trying to get the movement to stop. So the other thing too is that even if you can still have friction even if something is not moving. Think about something sitting on a slope. It's not moving, but friction is pushing up because gravity's pulling it down, and they kind of balance each other out. Okay, and then number four is maybe the most confusing, but it's really pretty simple. I think people just want to make everything tension, but it's really not that big a deal. So if you have something like a rope or a string that's pulling on something, that's a tension force. Okay. So really the key here is you have a rope or a string. That's what lets it be tension. And so like I said, 2 through 4 are actually all the electromagnetic force, just different ways of using it. But we're going to refer to them usually as normal, friction, and tension forces. And then gravity's gravity. Okay, so if you're watching this video, you're probably not going to be using a whiteboard, but you are going to need to be thinking about this and writing things down. So we're going to think about what are all the forces acting on a student sitting in a chair. Okay, so you probably should have come up with the normal force. We talked about that, right? And friction is pulling down, gravity's pulling down. So we definitely have gravity and normal force. Unless the person is like about to, trying to slide out of their chair or something like that, we probably don't have friction unless they're, there's really not any ropes or strings or anything or a chain, so there's no tension. It's really just gravity and normal force. Okay, next one. A student standing on the floor while Mr. Schober tries to push them out of the room for being rowdy. So what forces are acting on the student there? Okay, so there's Mr. Schober pushing on them, me, right? So we could call that a normal force because we have two objects touching each other. And so that would be an example of where, if the student is standing straight up and down and I'm pushing from the side, that force is going to be at a 90-degree angle to the surface of the student, right? So we got normal from me. What about normal from the floor, right? And there's one more big important one, and that would be gravity. And now, once I start pushing, though, that student is trying to push back, and they're trying not to get pushed out of the room because they're, being a rowdy student. And so they are pushing down on the ground, and, the ground is pushing back, and we call that friction. That's trying to keep them from sliding. So we could draw a little picture of that. We'll do more pictures in a minute. Okay, next one. A yo-yo hanging from a string. There are two forces on this one. What are they? Okay, gravity is pretty much always going to be one of our options, or one of our answers. So gravity is one of them, and then the force that's pulling the yo-yo up from the keyword here, string, is tension. So this one would be gravity and tension. Okay, next one. A car driving down the highway. Okay, so there's the... we'll walk through this, and then I'll kind of get you to kind of sum things up for me. So there are the tires are pushing one direction on the road, and the road is pushing back. And since that's two, they're kind of moving side by side, trying to keep the car from sliding, we're going to have one kind of force. We also have another force from the ground just pushing straight up on the car. And then we have some friction from, I told you. Well, I'll just go ahead and tell you there. Yeah, there's friction from the air because the car is moving through the air, so we're going to have friction there. So which of these forces are acting on the car? Okay, what about when the car decides to slow down? How are things going to change? Okay, so it still has normal force and gravity, right? Now, though, the friction force from the road is going to be pointing opposite direction, trying to slow the car down because we're coming to a stop, right? And we got the brakes on. Okay, so next up, we're going to talk about something called free body diagrams. And basically, we're just going to make a drawing showing all the forces acting on an object. And my advice for you is keep it simple, stupid. Not saying you're stupid, just telling you, keep it simple. And if you don't, then maybe you are stupid. Okay, so what we're going to do is we're going to use a box or a circle to represent the object. We'll do an example in a minute. We're going to draw arrows to show the size and direction of the force. Okay, so more tips. We're going to first just think through what are all the forces acting on this object. Then you need to think about what direction each force should be pointing. Is one force really strong and one force really weak? Keep in mind the length of the arrows should be important. And is there any other information we should include, like we're on a ramp or something like that? Then we're going to draw a box or a circle for our object, and we're going to add all arrows for our forces. Okay? So let's do some examples. I got to close this down to a little bit minimized screen here so I can get my pen. Okay, so student sitting on a chair. First thing everybody wants to do is draw a student sitting on a chair. And you know what? Here's my little guy. There's my chair. If you do this, that's wrong. That is wrong because I didn't follow my own rules, right? My rules were draw a circle or a box to represent your student. So here's my circle for my student. And we need to think what forces are on that student. Okay, so we definitely have gravity. So draw an arrow going down for gravity. And let's label that. We'll say force of gravity. We also have the chair pushing up, right? We kind of already talked about this example. That would be our normal force. So that is Fn for normal force. This doesn't say anything about sliding or moving back and forth or any ropes, so I think we're good with that. Okay, so let's go on to our next one. Oh, and I got to clear all my stuff here. Okay, so our next example is a yo-yo hanging from a string. So while I'm erasing, be thinking about what are the forces. We already talked about the forces, right? The yo-yo had gravity and tension force. So now how are we going to draw that? Well, first thing we're going to do is draw a circle for our yo-yo. Circle's pretty good shape for a yo-yo too, right? Then we need to think, what direction is gravity going to be pulling on the yo-yo? Yeah, so gravity pretty much always pulls down. And then we need to think, what about the string? Well, the string is going to be pulling up, working against gravity, right? So I'll put Ft for tension force on that string. So yeah, that's a pretty easy example. I'm going to go ahead and erase this one. And we will go to our next. Oh, I didn't do it right. Go to our next example here. Okay, so an airplane flying along at constant velocity and altitude. Okay, so this one's a little bit trickier. I'm just going to use a little box here to be my airplane. Don't need to draw a super complicated picture of an airplane. What force are we pretty much always going to have that points down? Gravity. So Fg. Now, if you're in well, we've had a couple of aviation teachers, but if you've had aviation, you probably know that we are going to have a force up. And this is not one we really talked about, but it's called lift. And really, lift is just another example of the electrostatic force pushing on stuff. It's the air molecules pushing on the wings and things, right? Okay, so we have that. Now, if we're flying along at constant velocity, remember, we're moving. So we have some velocity. We're moving through the air, which means there's going to be friction. Friction always resists movement. But if I'm flying along at a constant velocity, that means my velocity is not changing. I'm staying the same speed. That must mean I have another force going forward. So what is pushing this plane forward? Yeah, the engine or the thrust. We haven't really talked about that yet either, but that is another example. So like I said, I gave you my 4 favorite forces of physics, but there are obviously a lot more other things that we could talk about. So there's an example of another free body diagram. Okay, so let's look at our next one here. It says a balled up piece of paper in mid-flight after being thrown into the air. So what we're going to do is finish erasing this and draw a balled up piece of paper. I think a circle would be a good option for that. There's my circle. So it's in mid-flight, so it's moving. And what do we know? If something is moving, then we always have to have friction. Well, I guess we don't always have to have friction. Depends if there's nothing to rub or bump into. But in this case, on Earth, pretty much, we always are going to have friction. So there's my force of friction from the air. So I'm moving through the air. That's why when you throw a piece of paper, it slows down as it's moving, right? So it moves downward because of gravity. We know that. Pretty much always going to have gravity. But it kind of slows down because of friction with the air. Okay, so that would be that example. So really, I hope you're kind of getting the idea. These are not fancy pieces of art, right? I'm just drawing a picture, drawing a couple arrows, and labeling it. So if you're doing this online, you don't have your notebook, so you're not going to do an exit ticket. And if you're doing this on Edpuzzle, you can't really draw a picture, so you're kind of off the hook for our exit ticket, but you do have to do the worksheet about free body diagrams. So you can watch this video again as many times as you need to see what I'm doing with free body diagrams, but the worksheet should be pretty straightforward. So good luck, and I'll see what you come up with.